Hmm. IUPAC, International Union of Pure and Applied Chemistry. Yeah, I know I just made this lecture, but I'm making it again because last lecture was so trash. I just rewatched it. Oh my god. Even I wasn't able to understand anything from it. So, yeah, I'm making it again. Okay, wait. Let's not get straight onto it. First, let's understand something. Okay. For example, what is IUPAC? International Union of Pure and Applied Chemistry, which was set up in 1919. By the way, 1919. It's also the year when Treaty of Versailles was set up. Was done. I mean, say coincidence. Pure and applied. But let me change that. Pure chemistry means the type of chemistry you study in notebooks. That's always accurate. For example, if you will add A B C D plus U into F, you will get A B C D F. Always. But that's not the case in applied chemistry. Applied chemistry, you can say it's a 50-50. I mean there are chances that if like it might happen that the solution is same. Otherwise it will happen like you mix ABC plus into CDE and your friend does same, but you both might get different solutions or compound anything result, different results. Yeah, so it's not always known what you will get in applied chemistry. Applied chemistry is a type of chemistry which is used in industries, and pure chemistry is just academic one. So let's start. First, let's start with simple thing. For example, this. Okay, bonding in organic compounds. See, there are two types of bond. Sigma bond, you can see here. Let me zoom in, I guess. Sigma bond and pi bond. Pi bond is also known as multiple bond. Wait, here. So, sigma bond. Sigma bond is represented like this, while pi bond is represented like a pi. Okay, so a carbon has valency to make four pairs because it got four electrons in the last shell. I'm not gonna teach this topic. Okay, it's of ninth class, dude. I know you know it very well. Okay, so carbon can make four pairs, and it can also make pair with itself. Wait, what? Wait, wait, what? Yo, what the? Yo. Okay, what the shit? Okay, yeah. So carbon can also make bonds with itself. Yeah. Carbon can also make bonds with itself and with others. It's called catenation. Like it's a property. It's written down here. Catenation, the property of atom of an element to link with another forming chains of identical atom is called catenation. Basically, it can form pairs like C C C C C. Yeah, it use in IUPAC. Basically, we're gonna learn about hydrocarbons, in which is a carbon making bonds with hydrogen. I know, right? My writing's horrible, but it is what it is. You gotta deal with it. So like basically, it is represented like this: C H H H H, and most of the time, like here, especially here, this type of bonding is known as sigma bond. See, one straight line. It means it's one electron only sharing one electron with hydrogen of it. Hydrogen too have its own electron, so they are making pair. But in pi bond there are two types: multiple single pi bond and double pi bond. I'll just show in book, but wait a minute. So single pi bond. Single pi bond looks like this. See, two lines. So here carbon is making, you can say carbon is making pair with itself. It's donating its two electrons to another C. I mean, forming a pair with it, like C. He have its own two electrons. He have its own two electrons. Two are given by both two hydrogens. So now they use these two to form chains, and this is known as pi bond. It's called single pi bond. You may ask why? Because this one line is a sigma bond, and this another line is called the pi bond. So it's called one. It will be counted as one. Okay, this pi bond will be counted as one. But while there is the double pi bond, which looks like C, which is sharing three of its electron to another C and one electron to hydrogen. So in this case, there are two pi bonds but one sigma bond. I mean, like you will count these, so it will become three sigma bonds, uh, uh, three sigma bonds and two pi bonds. Okay, let's look at the example. So see here, total number of bonds, sigma bonds, one, two, three, four, five, five sigma bonds, and how many pi bonds? One. While in here, you don't worry about this name. I will tell you the name soon. It's known as ethine, but for now you can see. But let me zoom in. See three lines. See only the first line will be counted as a sigma bond. So one, two, three. Okay. Moving down, these are some compounds you can take. Okay, what's homologous series? Homologous series may be defined as a series of similarly constitutional compound in which the members possess the same functional group, have similar chemical characteristics, and have a regular gradation in their physical properties. Two consecutive members. Ah, shit, whatever it is. Leave it, okay? I guess you know about this. Just in case, I will tell you. See, here it's like expanded form and like bond line form. I mean, this was explained pretty well in my last lecture, so I will leave it to you. But still, okay, wait a minute. So, when we making a straight, carbon chain, it's called a chain, okay? It's a chain. Why can't I draw fucking straight? Okay. Yeah. Let me erase everything right now. Okay, the eraser is pretty small. It's gonna take me a while. Wow, it's taking a while. See, so the carbon, which is like this. See here, it's also making it, pairs. Like it will make three pairs. See, it got three, empty, and this will make with two. This will also make with two, because one it's making with another C, and the other one will make three. So, as you can see here, if you want to represent it in a bond line structure, bond line form, you will have to represent it zigzag. One carbon, two carbon, three carbon, four carbon. One, two, three, four. One, two, three, four. Is the ending is also counted? Every turn is also counted. That's why it is in curved. I mean, zigzag form. Otherwise, if it would be straight, how would you know how many carbons are there? Okay, so and in this one you might be wondering why it's cross and not plus. So it's a, I mean, there is a like good reason, because it comes in under new alkyl group. New alkyl groups have plus. Yeah, it's a, I will tell you in a few minutes. Okay, just wait. I taught alkane and alkyne in another lectures pretty well. So please check out from these alkenes and alkynes. Okay, I'm not gonna teach them again. Please, I'm sorry. Okay, and what about these degree of unsaturation? I will teach this at the end, because I mean, there is no really necessity of it. Okay, moving down, we have some names of hydrocarbon groups. Alkyl. Wait, let me. Hmm. Yo, hmm. So the names are alkyl, alkenyl, and alkynyl. See, the pronunciation is different, okay? I mean, not by my mouth. I got skill issues in English, you know that. But like, it's pronounced quite different. So alkyl, alkyl is you can say it's daughter of alkane. Alkenyl is the daughter of alkene, and alkynyl is the daughter of alkenes. Oh, alkynes. My bad. Why the fuck do I make mistakes? Okay. Hmm. You might wonder how. See, what's the formula of alkanes? CH3, uh, CH3, because two carbons. But, but, I mean, like you see, no, CH3, CH3 would be somewhere here. All alkanes. I mean, CH. I mean, this for your better understanding, or for my better understanding. See, this is the formula of this one. Like, I mean, this is not a formula. Formula is this CnH2n plus 2. This is a type of alkane. So when you remove one H from it, it can be either one. This. When you remove either one of H from it, C H H H H H, then it becomes a alkyl. See, alkane removed H, alkyl. The formula is of alkane is CnH2n plus 2, and of alkyl is CnH2n plus 1, because one hydrogen gets subtracted. Okay, same goes for alkene, same goes for alkyne. Nothing change. Okay, just removal of one hydrogen atom. So, and moving further, it's isoalkyl group. See, if you're not understanding anything right now, don't worry. Don't worry. Just watch it till I tell you the naming of it. Then I guess you will be understanding it better. So for now, this is the hard part. Took me a while to understand these two. So you can just take easy. Okay, yeah. So isoalkyl group. Isoalkyl group are something which have these things present. Okay, any carbon chain which have this shit present in it. Basically, when it would be like this. So this shit is present. It's alkyl group. Alkyl. Mother. Okay, sorry. It's a family-friendly lecture. I sometimes forget. Yeah, it have an exception. Don't ask why. See, even I don't know why, because it got more than two or three alkyl groups, isoalkyl groups. I mean, I don't care what's the reason. Just learn exception. See, I told you that there are no reason for exceptions. I mean, there are reason, but like it depends from person to person. So for now, don't. Okay. Same goes for new alkyl group. So see, new alkyl group have a plus in it. Like C. Alkyl, you might be wondering. See, it's new alkane actually. I mean, but see, one hydrogen gets subtracted, so it's CH2, because it will get attached to something else. So that's why. See, and don't forget to add hydrogens in each of these. Yeah, that would be pretty bad if you don't add hydrogens. So without wasting further time, let's just jump on the naming. Okay. uh, Let me pick it up. See, IUPAC naming is done with wait a minute, I'm just gonna check. Let me check. So yeah, it's prefix, it's suffix. So this is the order. So basically there would be five type of charts. Yeah, exactly. See, that's easy it is. There would be five charts and you have to pick each one thing from each chart and place it in this position. Secondary prefix, primary prefix, word root, primary suffix and secondary suffix. Just remember prefix would become pre, means before the word root, and suffix would be after. And see the order. Secondary prefix will come first, while secondary suffix will come at the last. Okay. What the shit. How to scroll down? Uh, what? Oh yeah, oh yeah. Got it. Okay. See, let's see. So what's the word root? See, word root. Yeah, basically we will be starting from word root. Word root is really simple. Word root just present how many carbons are present in a parent chain. Parent chain meaning the chain of the carbon. C C C C C. 1 2 3 4 5. 5 carbons are present. 1 2 3 4 5. 5 means pent, so it will be called pent. Done. Done. I mean, for now, done. It's pent. Okay. C C C. Only 3. What would be the name? Prop. Done. Dude, done. That's all. See, number of carbons, like you only have to do till 10. I don't think others would be necessary. I mean, they're not gonna give you hi-fi some MBBS type shit. Okay. Meth, heth, prop, but, pent, hex, or hapt, or non-deck. I mean, this is pretty easy. You will memorize it in a second. Okay. Moving further to primary suffix. Primary suffix will come after. So, like for now, its name is pent. Okay. It's our main base example. I will teach you from this. Okay. Everything I will teach you from this. Now, moving on, primary prefix. See, primary prefix is just asking you what type of bond is present. Yes, hear me out. What type of bond is present? The definition goes: a primary suffix is always added to the word root to indicate the whether the carbon is saturated or unsaturated. Unsaturated means if the carbon has single bond, sigma bond, only made up of sigma bond, and unsaturated means if it's made up of pi bond, it can be either single pi bond or double pi bond. See, saturated means sigma bond, only sigma bond. Then the prefix would be ane, alkane. See, remember, see in alkanes there would be only sigma bonds. In alkenes there would be pi bonds, but single pi bonds, and in alkynes there would be double pi bonds. I really taught you very well in the previous video. Okay, I'm not gonna tell this again. I mean, it's common sense. You will get it if you read this thing and make the structure for 3 times. Okay, so yeah, saturated. So we only gonna add the suffix. Okay, primary suffix. Oh yeah, my fuck. Wait, what? Oh yeah. I mean, sorry. My bad. I really messed up. It's suffix too, because it would be added after the word root. Okay. Oh my god, how much do I mess up? It's making me mess up. So there are total six. I mean, if it's saturated like this one, two, three, four. See, all three of these bonds are sigma bond. So it means it's saturated. So it would be named. The prefix would come ane. So this is called pentane. Just pentane. Yep, that's all. This is the name of this compound. It's called pentane. Now we'll use another name. For example, C. Here three carbons, but one. See, see here are. My bad. I guess I messed up in the last example too. See, there are three carbons, means prop. But here is a pi bond. Okay, here is a pi bond, and pi bond, single pi bond. See, the unsaturated with one double bond means one pi bond is called alkene. I told you that single pi bond will only be present in alkene and double pi bond will only be present in alkyne. Mark these. I mean, okay, mark these. For now, single pi bond will only be presented in alkene and double pi bond will only be presented in alkyne. So alkene means the suffix is "ene", so it would be called propene. But for example, if there would be double pi bond, the last one, the primary suffix would be propyne. Okay, these are the name of this compound. Okay, that's easy. I mean, if you think about how will we attach the hydrogen, so one hydrogen here, three hydrogen here, because this one already get attached in this, and it got three. Okay. So, so okay, moving further, these are three more unsaturated with two double bonds, unsaturated with two triple bonds, plus diene. For example, C. It have two double bonds. Okay, now so it would be in 1, 2, 3, 4 means prop, I guess. No, but. Yeah, but. So it would be but di butadiene. My bad. A will be included. Butadiene. And same it would be if here would be double pi bond, then it would be butadiene, I guess. Yeah, diene. Okay, and if there would be three. Wait a minute, where is it? If there would be three, I mean three, three triple bond. I mean, like, how many you add? The die will become tri, will become prep. Okay, you won't get further than these. Okay, butan here it won't be buta 1, 2, 3, 4, 5, 6. It would be hept or hex. What is it? Yeah, hex. Okay, so moving further, it's secondary suffix. Secondary suffix is then added to the primary suffix to indicate the nature of the functional group. See here, we are only going back. First we read, the word root, butane. Then we read the primary suffix. Now we're gonna learn the secondary suffix. We are only going behind. Yeah, we are not. We haven't yet started the first two. So a secondary suffix is then added to the primary suffix to indicate the nature of the functional group present in the organic compounds. Secondary suffix is important to the functional group. Okay, so what are functional group? Functional group, the characteristic of an atom which decides. See, the characteristics of group of atom which decides the physical and chemical properties of an organic molecule is called functional group. Functional group is portion molecule which is highly reactive. Okay, it's like the big top G of the house. Yeah, this is the person. This is the mafia guy. These all are just members. This is a functional group. Okay, OH. It's a type. It's one of the functional group. So if any functional group is present in any type of is attached to any type of carbon chain, Then this functional group will decide the chemical and physical properties of this whole chain. Like a mafia leader decides what the whole group will do. Same goes for this. This is the mafia guy, okay? Fucking mafia. Yeah. So functional groups are, in this order. See, R here represent reaction. I mean, like reaction in the carbon chain, parent chain. It's just, it means the carbon chain is attached. In most of the example, there would be only, there would be only one, but there are few where like both side the carbons of reaction carbons are attached. For now, you don't have to do these two, okay? These two won't come. Learn all these. You gotta learn all these. Alkanoic acid, alkyl alkanate, carbo. It's also called carboxylate. Yeah, mostly people learn the suffix name: carboxylic acid, carboxylate, carbonyl halide. What the fuck? By the way, this one, carboxylate, is also known as ester. Ester is the ester. Ester is more of its well-known name. In even the question, the ester would be given. This one is known as amide, nitrite, carbaldehyde. This one is known as ketone, ketone, ketone. This one is known as alkanol. This is alkanithione, whatever this is, and this is alkanamine. This is amine. See, these there are few which are same almost. See, amine and amide. It is almost same. Just there is not presence of this oxygen which is in pi bond, single pi bond. Okay, you gotta learn these. It would be added. I will give the examples. I will give the example. Wait a minute, chill. Okay, I will give the example. See, these are the example. Organic compounds: CH3, CH2OH. CH3, CH2OH. How will we make it? CCOH. Here would be 3H. Here would be 2H. Okay. So we'll count 1, 2. I mean, see, we have two carbons, means meth, eth, single bonds only, ane, and OH. Now let's see what's OH. OH means OH has the suffix ol. You might be wondering why a secondary suffix have its own prefix. The prefix is used in case there are two functional groups. Remember, two functional groups can be present in a single carbon chain. They might be attached here, and one can might be attached here. So I will teach you that later. But for now, just learn the suffix. So alkanol, yeah. So the OH is present means OL. So ethanol, yeah. The E would be yeah. Me, I forgot to teach one other thing. Whenever a functional group is present, the last word of primary suffix a, e, I, o, u, only vowels would be subtracted. A, e, I, o, u. So the why does it get up? So the e would be removed, and the name of the compound would be ethanol. You can see ethanol. We want to do this: CH3, CH2, CH2, NH2. Three carbons means prop. Only sigma bond, because CH3 2 there is no difference. Prop ane and NH2. NH2 means amine. Propane amine. See, that's easy. That's easy. Do the bottom ones. Okay. Let's moving further. Primary prefix. It's most easy. Finally, we are on the part where we're gonna, till now we only learned about Wait a minute. Fucking zoom in. Yeah. Till now, we only learned about primary suffix and secondary suffix. Now we finally gonna learn about primary prefix. And this is the most easy thing. When there is a cycle of carbon atoms present, primary prefix is used to is used simply to distinguish cyclic from acyclic compounds. For example, okay, like if there is carbon like this, so you can see the carbons are in a cycle. Each will have its two hydrogen. Carbons are in a cycle. Basically, the carbons are in a cycle. So cyclo would be added in the primary in the place of primary prefix. For example, 1, 2, 3, 4, 5. So pent, single bond, ane, sigma bond, single, I mean sigma bond, yeah. So cyclopentane. Okay. Okay. See, that's why they didn't even give example because they knew it's super easy. This one is super easy. There's nothing more to it. Primary prefix. Secondary prefix, however, is a little, you can say, handy. Secondary prefix have something known as secondary prefix comes up with something known as substituents. Now, substituents. What are substituents? Okay, so they are same as what we call functional groups. Okay, wait a minute, something happened. Yeah, so they are what I was saying. Substituents are same as functional groups. Also, okay, but the only difference are that substituents is highly less in the power. You know, like really less. These are co-leaders of a team. If this is the mafia, then these are the co-leaders. Their properties and their physical and chemical properties will also be applied to the chain only if functional group is not present. Otherwise, only 0.00001% of properties will be applied in the main chain. That's it. You can read it. These are the substituents groups: FCl, Br, I, fluoro, chloro, bromo, iodo, nitro, nitroso. See, when there is a two oxygen present, it's known as nitro, and when there is one, it's nitroso. I don't understand the logic myself. When there are two, there is shorter name, and when there are single, there's bigger name. And these are methoxy, OCH, three, CH3, CH3. That's why myth, oxy, C2H5, ethoxy, alkyl, CH3, methyl. Alkyl, you might be wondering why. It's just representing you C, meaning C don't have anything here. It might have something here, but it's not having anything here. Meaning a chain which is empty on one end. X. You can say X. Any chain that don't have anything here would be known as alkyl. Yeah, it's pretty sure it won't come anyways. It's C2H5 ethyl and propyl iso. Okay. See, T is the type of chart. Where is it? It's a bit up, but I will show you. See, this is known as T, T, and this is N. I'm just gonna tell you the meaning of it. N means normal. This is not necessary to write, but whenever the carbon chain is straight like this, don't have any substituents, these will be counted. This will be counted as substituents. Okay, anything that will come here. Substituents basically replace hydrogen atoms. Yeah, substituents do replace hydrogen atoms and take place. While mostly, remember, mostly functional groups are added after or before the table, because there are few such as you know alkenyl. I mean alkenyl. No, not here. Carboxylic anhydride, which is added between the parent chain. That's why mostly functional groups are added after or before a carbon chain. But substituents are added in place of hydrogen atom. So it could be like CCC, H, 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 H. But here it could be any substituent. Big thing. Okay. So substituents are added there. Okay. So yeah, I was telling N. So any chain, any chain which is made up of basically like normal or nothing, no substituents at all, is would be known as N, and the name like 1 2 3 4 propane. Propane. We would add N if it's just a simple chain. It's not necessary. It's not really necessary, but we do add it. Iso means that group, that kind of plus group. CH3, H3, H2. That would. Propyl means C. See, whenever it's propyl, alkyl, any form of alkyl, what the groups, alkyl, alkynyl, where any, if there would any type of group, one hydrogen atoms would be missing, so there would be this bonding sign that it's not yet bonded. Let's see a few example. CH3, CH2, Br. Mm, CH3, CH2, Br. Only single bonds. Okay. What do you think? It's single bond. Mm-hmm. So this is a structural form. Okay, in structural form you can see 1 2 means two carbons means eth, single you know saturated compound, so ene, ethane. Now Br, substituents are added before. Remember, substituents are the secondary prefix, which are the first thing that comes after the word root. So it would be, what's the suffix of secondary prefix for Br? It's bromo. So it would be bromoethane. Oh, you have successfully learned IUPAC. Well done, my child. Now there are few rules. Now comes that tricky part, and I will teach the rules in the coming lecture. Okay. How you do methyl. Actually, let's do for some examples. It would be better for you. Now it will do the example, because there are few rules. I'm gonna teach you few rules. Okay. There are not few, but many. But I will teach you with examples, so there won't be any hard thing. Okay? Don't worry.